Okay, so here is the practice work for Unit 7, Lesson 4. This one is a little less of a marathon than practice 3, so let's get right into it. It gives us this triangle on the coordinate plane. I labeled and color coded it. I know you really maybe can't tell so much. Yeah, these are color coded. My X's are blue and my Y's are burgundy. Uh, I prepared it to make this lesson a little bit easy, but I didn't really. And of course, my hypotenuse is orange. It's going to be the color scheme. Maybe I should start making my Y's red. But anyway, so I just transpose these numbers. They're nice enough to give us the numbers, the coordinates, and I just transposed them. And these are going to help us to figure out the length instead of counting the blocks for these. We can just do a before minus after to figure out what the actual distance is for the x and the y's, and then we'll use Pythagorean's theorem to figure out the length. But real quick, just some comments about this triangle, this series of triangles, right? R is a common angle for all three of these triangles. You have one triangle, then the second triangle that encompasses the smaller triangle, then the big triangle, so triangle small, medium, and large, right? Triangle small, then medium, and then large, right? R, H, B, R, S, N, then R, M, T, right? I was going to say small, medium, large. And but R, this angle R here, is in each one of them. It's the reflexive property. R equals R, and R is shared inside of each one of those triangles. And the first thing here is it's asking us why are these triangles similar? It says they're similar, but why are they similar? Well, if you can remember from last unit, well, how many? There's three ways to say things are similar. The triangles are similar, right? There's angle, side, angle. There's side, side, side. There's angle, angle, and then there's side, angle, side, right? Um, this is obviously right. We're shown that these are right angles, right? So we're given three right angles, and then we're given this angle here for all three triangles. So we're given two angles for each of the three triangles. So because of the angle-angle similarity, and let me use a neutral color. I'll use green as a neutral color. Angle, angle, angle similarity. Similarity. All three are similar. Similar, right? 90-degree angle, angles, and angle R. Okay. And then you could even say, well, what are the proportions? Prove that they're proportional. In order for them to be similar, they also need to be proportional, right? So that's one portion of it. They share they share two angle measures, right? But they also have to be proportional, right? So the first angle measure, the first proportion we can say is we'll just say one length here. We'll just pick this length, or we'll pick this length. Why not? So this length, or we can't use the negative 2, right? Because that's the x value. So we'll use what's the distance of this? Well, 7 minus negative 5. 7. So the distance between 7 and 5 plus negative 5 equals, that's 12. Okay, so 12, and then so 12, and then we'll say, so that 12. So we'll do this over this. We'll see what that thing is there. So difference between 2 and 7 and 2 there is 9. So the x, so the difference between the proportion of the x into the y is 12 over 9. That equals, oops, 12 ninths equals, let me do 9 over 12. I really don't like 9 over 12. 9 over 12. 9 over 12 equals, that's 3/4. Okay, so let's see if that one, how about this one? Let's go 3, difference between 3 and 5. 3 plus 5 is 8. That's our bottom one. Or this is x over y, what we're doing here. So 1, difference between 1 and 7 is 6. Okay, 6/8. That's 3/4. Okay, so that one's the same. And how about let's see, the difference between 7 and 4 is 3. Difference between 1 or -1 and 5 is 4. So that's all the same. So the proportionality is all the same. So therefore the triangles are similar. Okay, there we go. So that's how you answer that question there. All right, so we're going to be flipping back and forth between the front page and the second page here. Hopefully I don't lose. Okay, yeah, that should be all right. I can put my stuff here so we can just ignore the next one. I can slide it over a wee bit more. Hopefully I don't bump my camera and lose it. Okay. All right. So let's before we move forward here with this, we have the little HRB, H, S, and M. H, S, and M. This is little, medium, and big triangles. Okay, and then we'll kind of see which one is which here. M to T, S to N. So M to T. Oh, we're gonna put a little one here. All right. So H to B. B to H is, this is our B to H. I'm gonna pull up. All right, so B to H, that is our Y value, our up and down. All right, B to R. B to R is our blue value or our X value, and that means that this is our Z value. And all right, and that pattern's gonna repeat itself. Like that. Okay, and we kind of already identified these lengths already. All right, it's 9 and 12, 6 and 8, and 3 and 4. Bit medium. Oh, this should be. This was our medium, our large, medium, and small. X and Y values here. Okay. All right, so I'm gonna get my blue numbers. That's my X values. Blues are X. So 9, 6, and 3. 9, 6, and 3. Okay. Oh, I got that backwards. Nine, 6, and 3. No reason to do rework, right? Okay, it just slows things down, right? And then it's gonna be 4, 8, and 12. it's going to be 4, 8, and 12. Okay, so now I just got to figure out z for each one of these with Pythagorean's theorem. All right, so 4 squared plus 3 squared equals that. Take the square root of that. That means z is going to be equal 5 for the small one. Uh, 8 squared. I could just do the big one, get the whole thing. 12 squared plus 9 squared equals that. Take the square root of that. The whole thing's going to be equal to 15. I bet that's going to equal 10. 8 squared, because it would have to equal 10, right? 8 squared plus 6 squared equals, bingo bango. Oh, you can't even see the stuff I'm doing, can you? Because I'm doing it on equals 10. All right, so there you go. I got all the lengths there. Okay. That was just Pythagorean's theorem. Remember, x squared you can't see that. I'll just bring that down a little so you can see that up here. Remember, I did all that by doing x squared plus y squared equals z squared. And that's how I figured out z for each one of those. If you're not on that so far, you're a little behind the power curve. Okay? Come talk to me. I'll catch you up. All right. All right, so now we got to figure out cosine. We have all the information we need right here. We don't need to look at this. Okay? All right, and the reference angle is R. R is the reference angle. Okay? So just we'll take a real quick look at this. Right? R is our reference angle. Our opposite is our burgundy. Right? Opposite is our y values. Our adjacents is our blue values. Right? Opposite. Adjacent. Hypotenuse. There you go, just like that. Okay, so our cosine is, I like doing sine first. I don't know why, because it's sine. It's in SOHCAHTOA. It's sine, cosine, tangent. Why they do cosine, sine, tangent, I don't know. No, it's always opposite. They always teach sine first. But anyway, I'm gonna do sine, cosine, tangent. All right, opposite over hypotenuse. Right, so it's gonna be y over x. Right, so it's gonna, for the little triangle, this is little, medium, big again. Right, it's gonna be little, medium, and big again. Okay, so we're gonna start with this one. All right, so it's gonna be 4/5. Goes 4. That's our opposite over hypotenuse. Because sine equals, our sine is sine equals y over z, or opposite over hypotenuse. Cosine equals x over z. And this is only for this angle, right? If we were going to use like this angle, it would be the opposite. It would be opposite for like this angle. Um, for like angle X, our sine would be our X value over the hypotenuse. Okay, so let me for this angle, these are the definitions. Okay, for this angle. Okay, don't get, this is not true for all angles. It's just for this angle. Okay. Over Z, and for tangent, this angle in this problem. Okay. And then for tangent, let me use green. Tangent equals opposite over adjacent, and in this scenario, it's y over x. Okay. All right. So again, it's 4/5. 4 opposite 4/5. Yep, 4/5. See, all these are going to be over 5. And they're all going to be less than 1. Oh, no, they're not all going to be 5. This is going to be 10. And this one's going to be 15. This one's going to be 10. Because this is the hypotenuse, and this is going to be 15. Okay? Alright, so this one is going to be 8. This one is going to be 12. Right, now we change the x values. X is going to be 3. This is going to be 6. And that's going to be 9. Alright. And then we're going to do our tangents. These are our x values. So I'm going to get my green out and make some. Okay, so I got my blue out, so I'm going to grab my adjacents, opposite over adjacent, so 3, 6, 9, and then I'm going to grab my opposites, 4, 8, 12. Tangents can be over 1, okay? All right. And it should make sense to you, right? If your tangent, if your opposite angle is longer, or if your opposite length is longer than your short length, than your adjacent length, it's going to be greater than 1. Okay, that should make sense. Because these are just ratios, right? All right, so now we'll do some maths. Typically round these to the nearest hundredth. 0.060. That means that the adjacent length is 60% as long as the hypotenuse. That shouldn't be surprising. Also, same thing. Shouldn't be surprising. Okay, 4/5. It means that the opposite side, the opposite length, is 80% long as the hypotenuse. 80% long. Long. If one of those comes out different, it's probably a mistake. Okay. 4 divided by 3, that's 1.3. And 12 divided by 9, 1.33. Okay, so this exercise was to show you that the ratios, because the similar triangles, the ratios are the same. Okay, sine, cosine, and tangent are just ratios of the lengths of those triangles, of one length of that triangle to the other length of that triangle, right? This is saying that that opposite length is 33% longer than that short length. That adjacent, the opposite side is 80% as long as that hypotenuse. The adjacent side is 60% as long as that hypotenuse, because based upon the angle R. Okay, that's what all this stuff means, right? Now they just leave sine, cosine, and tangent in these different, into the decimal forms, right? Because it's easier to do math with. Okay. Okay. Now we round. Now we're going to round the value of. If we're given this trigonometric ratio, all right, we're going to round the value of these to the nearest tenth or thousandths. They want us to do these nearest thousandths. So this is just a calculator thing. Cosine, I'm going to do blue, right? Because that's the adjacent angle. And I sometimes do use blue when it's generic terms, right? So you do, in order to do this in the calculator, do 53, and you push the cosine button. Okay, so it's going to be, it'll be 0.602. I got to round this 8 into 1 to make it 2 because it's rounding it up. That's great. If it's 5 or greater, you round it up. Okay. Now we're gonna do 53 and press the sine button, and it's gonna be 0. Okay, so this one's a little funny. Not really. It's gonna be 0.799. Right. So if this was a 9, right, you'd have to roll that into a. You'd have to roll this one into a up, and then you'd have to roll that one up, and it would be 8.00. But it's not. This is a 9. This is an 8. So it's just 7.99. Okay. And then the tangent of 53 tangent. Making tangents green. This is 1.327. Okay, so again, this is what all this stuff means, right? This one means is that if the adjacent angle, or the adjacent side of this angle is about 60% the length of the hypotenuse. The opposite length of this angle, 53 degrees, is about 80% the length of the hypotenuse. This one means that if the angle is 53 degrees, the opposite side length is about 33%, about a third longer than the adjacent side. Okay, that's how you can kind of read these things and put some actual value to what these numbers mean. Okay, and kind of visualize it in your mind. Okay, you can kind of see it over here right? We said the tangent this is 1.3. The tangent of this, right? This was like 1.33, right? That is actually 1/3, right? So this is saying that this length is about 1/3 longer than this length, right? And if you look at at here, you can see it is about 1/3 long. It is about 1/3 longer, right? This is 3, that was 4, right? So that's about 1/3 longer in units, right? So that should make sense to you guys. Okay. All right. Hope this makes sense to you. Trigonometry is awesome. Sine, cosine, tangent, my favorite functions. I like sine the best, and it turns up in electricity a lot. Okay. Well, you guys have a wonderful day, and I hope you got some out of this.